Hello everyone, and welcome to our latest installation of installment, I should say, of Build Your Simulation Mechanical IQ. Today's topic is working with contact constraints and Autodesk Nastran In-CAD 2016. My name is Marwan Azzam, and I'm a technical support specialist. And with me today presenting is Allan, Fowkes, who is a simulation technical sales specialist. We are going to go through a couple of examples here, working through the In-CAD inside of Autodesk Inventor. We're going to bring up a couple of models and show you how to set up the contact. Before we do that, though, we're going to go through a couple of slides here, general slides, some resources, and so on. Our Autodesk Help webinar series, we do webinars on different topics, including simulation CFD, simulation mechanical, and in this case, simulation Nastran In-CAD. I encourage everyone to check those out. Those are usually about 45 minutes to 1 hour, where we go through a presentation, show a couple of models, and take questions. And we do post the data set on a Box website where you can download that. Build Your Simulation Mechanical IQ, we have live monthly technical discussion. It is hosted by Autodesk Simulation Mechanical Technical Support Team, which is me, Andrew, Dean, James, all of us here. These, like I said, are 20 to 40-minute demos / discussion followed by QA. Topics chosen based on previous data extracted from webinar surveys. Popular simulation mechanical webinars are Introduction to Nastran In-CAD for simulation mechanical users, Simulation Mechanical 2015 R1 with Autodesk Nastran. Well, that's an older one, but it's popular. Introduction to MES. Upcoming topics, that would be on July 2nd, limitation of using forces as mass. You can sign up. So you do have to sign up and get an invitation for these. You don't just join right away. You have to sign up for them and you will get the invitation. And we do also encourage you to go to our SimTV on YouTube. What's in the news? This was presented last week. We have also a new slide here, supplemental results app. So we have a couple of apps here that are add-ons basically to Simulation Mechanical 2016. This one was launched on the 19th of this month. Enhanced support for Nastran contact setting, better post-processing for reaction forces and moments. This is the app. Some older news is, of course, for those of you who haven't checked out yet, we retired our subscription, old Autodesk Subscription Center, and we have the accounts.autodesk.com. We repackaged Simulation Flex. Of course, we launched all the 2016 products a couple of months ago, so we encourage everyone to take advantage of the latest version of the software, which has enhanced features and performance. And we, of course, encourage you to go to the knowledge base, Autodesk Knowledge Network. Check out the new articles that we add. Every day we add new articles dealing with different issues that people encounter using our software. These are very important and useful resources. Another thing that is new, we added a tutorial to the Nastran In-CAD set titled Introducing Autodesk Nastran In-CAD. So you can check that out. That's accessible through the documentation. This slide here just shows some mechanical and Nastran newly added knowledge base articles. Like I said a minute ago, I do encourage everyone to go in there and check out the new articles that are published all the time. These are troubleshooting articles and how-to articles and so on, commonly asked questions. Today's topic is setting up contact in the In-CAD environment. In-CAD is available for Autodesk Inventor and SolidWorks. So it is basically a user interface for our Nastran product solver. So you can have a part or an assembly that you open in Inventor or in SolidWorks, and then you access the In-CAD environment where you set up the finite element analysis in there, and you run it using the Nastran solvers. And you can also, of course, write out the text file, the Nastran deck, and if you want to edit that, you can do that on your own. You can open it either in a text editor or the Nastran interface, where you can edit the deck and launch analysis as well. But the In-CAD itself is basically a user interface that is built into Inventor and SolidWorks. Today, of course, we're going to be working inside of Inventor. A couple of slides here, 3-4 slides that talk about contact. If you set up a contact pair, you're going to see the screen here that we see the surface contact, where you can set up some parameters, stiffness factor. Over here, contact is built using spring elements basically between the opposing surfaces that are going to be in contact. And the stiffness factor by default is set to 1. It uses some calculated stiffness. If different materials are connected, it can be adjusted and up or down. And if you have very different materials or very different meshes, you might need to adjust that value up or down. You can also add friction to your contact pair by adding a friction coefficient. Of course, whenever you do add friction, it makes the convergence a little slower. So we do recommend that you test the model without friction first. And excuse me.
Okay. Because I can fix it right now.
Okay, sorry about that. So we do recommend that you test the model without friction first, and then when that runs fine, you can turn on the friction and run it with friction, just basically to make sure that the model runs fine, and you're not going to be spending too much time with friction where something else in the model needs to be taken care of. Another parameter here in the contact parameters is the penetration surface offset. This defines the full distance between the surfaces. This comes in very handy if you have, let's say, shell elements that are modeled at their midplane, and they actually would touch each other before the meshes touch. Because the distance between them, you're going to add half the thickness of each shell, so that's going to change the distance between the meshes. So you can change that parameter to reflect the actual gap between the two parts. Maximum activation distance, that's another parameter. Contact pairs are generated for all elements inside this tolerance. So anything that is outside that tolerance will basically have no contact elements built for it. If you have too big of a maximum activation distance, you will end up with too many contact elements, which of course will result in a longer runtime. If you have a too small of a maximum activation distance, contact can be missed because you would be missing some elements. Allowable penetration defines how far the contact surface can go through each other. More allowable means easier convergence, but could be less accurate. It is always a good idea to go with the defaults at first and modify those parameters as need be. Of course, we're not going to go into questions now. What we're going to do here is, well, you can type in questions as we go, by the way. What we're going to do is do the first example. So in this example, I have an assembly inside of Inventor. It's actually a 4-part assembly. This part, basically a joint, this part, the pin and the color here on the pin. To get into In-CAD and Inventor, we click in actually version 2016. We moved that to be under environments. So you click on environments. That was a little bit different in 2015 and 2016. It's under environments, and you click on the Autodesk Nastran In-CAD. Once we're here, we start setting up the model. So we're going to click on the plus sign next to model. We're going to define a couple of materials. So we're going to have the pin and this little part here, one material, and those two parts here, a different material. So we right-click, we define a new material. We're going to select a material from the Autodesk material library, which is the Nastran material library. And let's say these are some kind of carbon steel called drone here. It's not really very crucial for this example what they are. With these material properties. And the second material, we're going to make it actually stainless steel. This guy here. And we're going to click close. Since we haven't defined physical properties yet, we can't associate any physical properties or parts with that material, which is fine. Next thing, we're going to define a couple of physical properties. They're going to be similar, but we need two for the two different materials. They're going to be solid elements. Everything is going to be made out of solid elements. And for that physical property, we're going to select this part and also this part here, and those will have the one material. And the second physical property is going to be this part here and this part, the pin, and that's going to be actually the stainless steel. And before I go any further, I just want to make sure that this is the carbon here. And if I go actually back to material, you'll see that this material is associated with physical property 1, which were these two parts. Next, I'm going to define some constraints. I'm going to select these surfaces. These are going to be X symmetry. This, and this surface are going to be X symmetry. And another constraint is going to be fully fixed on this surface here. As far as my load, I'm going to rotate the model a little bit and apply a surface force on this surface here. So I right click and I define a new load. And that load is going to be minus, let's say 150 pounds in the Z, that's actually be Z, not X, total force on this surface. And just make sure I got the correct direction, yes. Let me just save my work here at this point. And now to let's do the mesh next. We can go here and change the global size to, let's say, 2.5, make it a little bit tighter, and update all the meshes. And here we go. And this actually might take a little longer than we want. Let's make it 3, just to relax the mesh size a little bit so it takes a little less time to analyze. It's not going to make much of a difference. Next thing I want to do is to define the contacts. You can define the contacts a couple of ways. You can right-click under Contact, for instance, down here, where's my contact, surface contacts, we can create a new contact pair. Or in a case like this where everything is originally touching each other, or the surfaces are touching, there are no gaps, I can go up to Contact and click on Automatic. And what that will do, it will go through the model and pick up all the surface pairs that are touching each other and create those contact pairs. Let me show you how that works. So I'm going to click on Automatic. And that automatically creates this entry here and populates it. And here it is. I'm going to expand that a little bit. So you got all the possible contact pairs, and by default they are set to, if I edit that, they are set to bonded. Okay? And in fact, I'm going to leave this first contact pair as bonded. And this is a contact pair between the pin and the collar here. Those will be bonded together. Everything else I'm going to set to surface contact. So I'm going to go through these remaining contact pairs real quick. Let me show you. First, what are the possible contact types that you can set? And by the way, this little bubble that pops up here that says Nastran welded, this is the older naming. So we used to call that welded. Now we're calling it bonded. And if I click here and expand it, separation is basically the fully general contact. Parts can slide against each other, they can separate, and of course if they're pressed against each other, they're going to resist that penetration and establish contact. So separation is the general contact. Bonded is they are basically glued together. Sliding / no separation, as the name suggests, they can slide but they cannot separate. Separation, no sliding, is the opposite. They can separate but they can't slide. And offset bonded is when you have a gap between them, but you want to designate that they are actually bonded, even though there is a gap between them. So you don't have to go in and modify your CAD model that might be generated with some tolerances for manufacturing. You want them to actually be bonded for the purpose of your finite element analysis, but you don't want to go back and close these gaps. You can define contact pairs and designate them as offset bonded. In this case, all of these are going to be separation. So I'm going to go real quick here and edit them and set them to separation. So right now what I've done so far is I have meshed the model, defined loads, constraints, and defined all my contacts. The one is bonded and the rest are separation, which is basically fully general. They can separate and of course they won't be able to penetrate. At this point I am ready to go ahead and run the simulation. So I right click here and go down and click on Solve and Nastran. So of course, since this has contact in it, it's going to be an iterative analysis. That's why it takes a little longer than if this assembly was all bonded together. But of course, if it's all bonded together, it's not going to give you the results that you would expect in real life. And this shouldn't take too much longer here. Okay, now so solution is complete. We're going to hit OK, and now we can review the results. First thing you want to look at, of course, whenever you do have contact, is the displacement. You want to make sure that the displacement looks right before you go ahead and look at the stresses or anything else that you want to look at. So we right click, go to Edit, Displacement. In this case it's a percentage, that's fine. We want to exaggerate it a little bit. We don't expect displacement to be huge. We're going to click on Display and look at the displaced shape. Or so we think. Displacement. There we go. So the maximum displacement is, as we can see, let me just move this a little bit, 1.383 e to the minus 3, which is a small number, which is what we would expect. If we look here, the way the parts are separating from each other, again, is what we would expect. This here is 0. So we're going to say, okay, that looks good. It's doing what we want it to do. Parts are separating here on the back end, and they would be supported here in the middle, and our pin is bending like that. We can look at the von Mises stress here. Display. Maximum is over here. Nothing is out of the ordinary. From the options here, you can change that to either percent or actual and so on. Let me just real quick here though show you what the different options for results are. There's a whole list of results. You can plot all these stresses, principal stresses, stresses in the different directions, displacements up here, rotation. We also have, I think somewhere, we have the contact status, and contact force should also be available somewhere in this list. Safety factor, contact force, all these are items available for us to look at. I don't know at this point if Al has a model that he wants to share with us. Al?
Yeah, sure. Yeah, we just wanted to present a couple of models. Yeah, so I can take the reins here, Marwan, if you want to.
Okay, sure. I'm going to change the present. For some reason, okay, hold on. Let's make Al. I don't see you listed here.
Yeah, I am the second Marwan actually.
Oh,
Marwan. Somehow I got.
There you go. Al, you should be presenter now.
Okay. Let's see. My screen. Yeah, somehow I just got listed under a different name there. Okay. You see my screen?
Yes, we do.
Okay. So yeah, just another example of contact. This one, I'm not going to go through a lot of the setup. I think it's similar to what Marwan just showed you in his example. But this is another pin constraint, and just coming from a different perspective on contact. What I've done in this model, I'll go over the constraints and the loads. For the surface contact, I just went down to the surface contact and I clicked New. You can see I already have a pair there, or a contact setting already defined. And I'm going to, in this case, just edit it just to show you what I have. This is just simply separation. Since we have such a simple model with two parts, we don't have anything other than just contact in the model. So there's no bonded surfaces, whereas in Marwan's, it was a great example of showing here's where I'm going to define bonded contact in another region. I'm going to have separation, etc. In this case, I'm just going to leave the default for all of the contact types set to the separation. Yeah, I typically use the defaults, and as we mentioned earlier, perhaps adjusting the stiffness gets your contact surfaces close to each other, as opposed to possible penetration or small gap that might be unacceptable to you. In addition, I've gone to the meshing and of course I've set my element size, but I've also turned off the continuous mesh to make sure that no nodes become actually bonded and I'll typically do this on simple models, or I'll go into the actual contact menu and we can adjust our maximum activation distance. And that'll basically allow parts to contact when they're within that distance. But in this case, very closely associated nodes, basically the surfaces are flush, so we expect the contact tolerance to be picked such that there's going to be contact initially in the analysis. One other addition, I'll talk about the constraints and loads next. The constraints are pretty simple. We've fixed this particular face, and these blue or light blue icons indicate the contact, or I'm sorry, the constraints. I'm just going to edit those to show you those. I have on those faces, there are actually two faces here, and I've fixed the entire face. Something a little different, loading, I'm going to talk about the loading also. There's an upward load on this surface underneath the handle. And again, I've already defined that, but that's just a upward load in the Z direction. And on the pin itself, I've got some constraints. I've pinned that center constraint. You can actually take a look at it. So on each point, I've really just got a pin connection at those locations. And what I've done in addition, just to show you some of the capability within the Nastran In-CAD, possibly it'll help you for, in this case, it'll help for stability with this contact model. What I've done is I've added what's called a rigid body connector from the edge to the center node, and that center node is what I have fixed or pinned in this particular case. So I'm going to come up and we're going to run the analysis. Again, as we saw before, you can always look at the output even once the analysis is finished by clicking the Autodesk Nastran output field or tab. Here again, you're seeing, as Marwan mentioned, the iterations, and that's basically because we've got to determine, the solver's got to determine whether surfaces come into contact, generate the contact forces between them, activate the elements and the stiffness between surfaces, where surfaces come off of each other, disable those stiffness terms between the surfaces, and keep iterating until there's really no change in that status of contact, and that's what we call a converged contact analysis. So you can think of it as running a series of linear static stress analyses where we determine what surfaces have come into contact and which ones have not. So this solution is complete. It will have results available immediately. Here's the contour. I'll turn on the display shape. This will be a little over-exaggerated, but you get the idea. Here's where you're seeing the separation between the bolt, the pin, and the handle. And of course, as we just saw in the last example, we can go into options and actually control how much of that display shape you want to exaggerate. So just another quick example of contact and how we can work with either individual surfaces and define those, in the setup, or just go ahead and define everything as a contact for the whole model. And that's really the end of our presentation for the contact. Should we turn it over to Q&A, Marwan? Or?
I had one more thing I wanted to show, and we also have 3 poll questions. We usually present those poll questions in the beginning. Today we're making them towards the middle of it. So let me go ahead and
Switch you back to the...
Yeah. I have another thing I also wanted to show, because so far we've seen a couple of ways of defining contact here, which is either create the automatic contact where it goes in and looks where you have surfaces touching each other, and you can basically select what kind of contact you want to have between those surfaces, or like what Al showed us here is basically default for the entire model. Well, someone might ask, well, what if I just I had 2 separate surfaces that are going to come in contact with each other, and I actually wanted to define contact between them. How do I do that? I'm going to show that in this model. We will not actually run it, but nonetheless we'll show how to do that. But before we go into that, let me just go and present those poll questions. So the first question is, I'm going to launch that. How would you define yourself? Are you a designer, an engineer, an analyst, a student, or other? So we'll take a few seconds here to respond to that. Okay, I think everyone pretty much answered there. So we're mostly engineers, some are students, and the lesser part, but that's changing. Let's see. We're still voting here. Numbers are changing. 50% of you, 54 voted. All right, so basically, give that a few more seconds. All right, so more votes are coming in. Okay, we're going to say that 60% engineers, 20% analysts, and at this point, 13% students. Let's go to the next question. Let's see, did someone else take control of the poll here?
Okay, Marwan, I went ahead and showed that so everyone can see the results there.
All right.
We can move on now to the next poll question.
Okay. All right.
So the next one is, what is your CAD program of choice? Give everyone about 30 seconds here to vote. So it looks like the majority of folks have voted here, and everyone is an Inventor user. So that's good to hear.
Good.
And we can hide that, and we'll just jump on to the last one. So have you guys used Nastran In-CAD before? Maybe this is your first time getting exposed to Nastran In-CAD with this webinar. You may have used a trial of it, or you've purchased it and you're just starting to get up to speed with it. Or you may use it every day. You may have been an NEI Works user, so you're fairly familiar with the product. So we'll give everyone a couple more seconds here to vote. All right, and we'll go ahead and close those and share those results. So it looks like a lot of you, majority of you, are still kind of getting to understand Nastran In-CAD and you're maybe not too familiar with it, but there is still a good chunk of you that use it every day and quite often. So that's good to hear that hopefully you're picking up a few tips and tricks here with this latest webinar session.
And for those of you who might still have the question, what is Nastran In-CAD? Hopefully we answered that, but if we didn't, it really is a user interface into our Nastran solver that is built into Autodesk Inventor and as well as SolidWorks. So it's basically a program that allows you to set up and run the analyses using the Nastran solver. That's what, in a nutshell, Nastran In-CAD is. I want to show you a couple of things on this model. First of all, like I said, if you don't want to create all the automatic, let's say you have a more complicated model, and you don't want to create all those automatic ones, and you just want to create ones by hand, that's also fine. What you can do is you can go down here to where's our surface contacts, you can right-click, create a new one, and let's say you can specify contact regions. You check that box, and we can select a couple of surfaces here. This surface, and rotate the model back and select this surface. So now we have created a contact pair by manually selecting two surfaces. Let's say we also wanted to create a contact between this block and this small stopper here. What I want to show here is how you select the surface that is basically hidden, which is the small surface on this part here. So let's create another contact pair. The big surface is easy. It's this surface we selected. Well, then how do we select the small surface? Well, then we do this. We select anything here, let's say the edge, and we left-click on it. Or actually, I shouldn't have left-clicked on it. Let me remove that. If you, by mistake, select something wrong, you can select it and delete it. Again, we select this, right-click, not left-click, and go to select other. And this will basically list everything that is at this location. Edge, face, and obviously what I wanted to select is this number 3, face. So this can cycle between all the entities that are at that location, and I can just select the one that I want, this face, and this would be this guy here, face number 1, and I hit OK. That is a very neat trick to know, otherwise doing your selection might be very difficult. And by the way, that's not only particular to selecting surfaces to define contact. That's for anything else to select for defining a load, defining a constraint, whatever it is. You can right-click like that and then cycle through the available entities at that location. Yeah, I wasn't going to go and do this model, but basically I've done it where you apply a pressure on this surface, you pin this edge, and basically close the gap between those two parts, and you press up on the stopper here, and you can have sliding between this part and this part. So all the contact pairs would be the general separation, even though you can have no separation sliding between those two parts. That's also another way of doing it, because you don't expect them to separate, just sliding against each other, which would make it faster to run if you do that rather than make it fully general, which is the separation type contact. That's all I had for this presentation. Go back here to the PowerPoint, see if anyone has any questions. Actually, this will be posted, and this would be SimMech 12, not 11. We will have the PowerPoint presentation as well as the modeled files. Andrew, do we have any questions?
Marwan, it looked like we did have a question at one point here from Darren. just asking about the different types of contact. You know, I was wondering if we had a type of contact with infinite friction, essentially a bonding contact, and so there are 5 primary types of contact in Nastran In-CAD. We have bonded, offset bonded, we have separation, sliding with no separation, and then separation, no sliding. And then you can obviously use connectors like rigid beam elements to connect parts together, but the 5 primary types of contact are the ones I just mentioned there. So if anyone does have any questions, you know, don't hesitate to use the questions box on the right to ask anything that you may have, not necessarily related to contact or what was presented here today by Marwan and Allan, but anything else about Nastran In-CAD that you may have questions about. We have another question here from Daniel. So by default, the boxes are not considered one solid, and that's correct. So this was brought in, I believe, Marwan, as an assembly. So each one's a separate part, so you'll need to define a physical property and then materials for each physical property for each box. So you can go in and define them separately as well. You could also, if you wanted to define them as shells, you could just select the outer surfaces and then mesh those, and you'd have a shelled part instead of a solid part there. Let's see, another one from Darren here. Is there any memory tax for using one contact type over another? So something like a separation contact or the Nastran talk, a general contact type, is definitely going to be more memory and computationally intensive than something like a bonded contact type, especially if you're doing you know, separation, and Marwan showed the max activation distance there, I think, in one of the initial slides. So that's going to vary how many contact elements actually get generated. So if you specify a very large value there, there's going to be a lot of contact elements that get generated, which is going to cause your analysis to run for a very long time. Whereas if you do something like a bonded contact, that's much less computationally intensive, but obviously that may not fit the needs for your scenario. Can you change the mesh in a part, asks Dominique. So let's see. So if you wanted to...
Yeah, so mesh sizes, basically?
I may be asking about doing that kind of shell approach I was talking about that I think Bart showed off early on in one of our previous webinars. I don't know if you could clarify that question for us there in the question box. So we have another question here. When using contact for linear static, is it possible to define it by parts and not by surfaces? So the only selections we're going to have, I believe, for generating a contact pair are going to be edges, surfaces, and we may have vertices on there as well. So Marwan, if you click the manual contact type up there on the ribbon real quick, we can take a look and see what we can filter by. So if you click the specify contact regions box there. Yep, and then we can right click. Yeah, all right, so we can select a body, face, or edge there when defining contacts.
So really, you would have to do it like this, because if you click on something, so let's say we want to specify that the first entity of the contact, I'm not clicking on the entire body here. I'm either clicking on an edge or on a surface, but if I right-click on it and select other, then solid becomes an option that I can select. So now the entire body is here. Let's say with this surface. Of course, in geometry like this, that probably doesn't make so much sense, but depending what you're doing, if something conceivably all the outside of one part might come in contact with a surface or the outside of another part, then yes, you'd want to do that.
All right, looks like we got another question here from Daniel. So I was looking, if I flush and mate parts in an assembly, do I need to define surface contact for every part? So I don't know if you want to tackle that one, Marwan.
No, that's what Al showed, and that you would make the default a certain contact. So I don't need those. Actually, maybe the other model would be, well, this is good too. Oh, yeah, I should guess. So in this case, surface contact. Let's see, where's my contact setting here? Contact. Automatic, we don't want to do that. Results. So basically we want to set that it's bonded, which would basically bond these two surfaces and this surface here and the one under it. So do we have to define it, Andrew, or it's just by default that's how it considers it?
So there's a couple different things we can do here. If you have a continuous mesh, then those parts should grab across the boundary there. If you go over to default settings, Marwan, you can actually take a look at what the contact settings will be used for when using that automatic contact. Yep, so if you click there, let's see. Okay, actually, if you go back, Marwan, click OK. And then under Analysis 1 in the tree, yeah, edit there, and select Edit.
Oh.
And we can actually now define what contact type is going to be used when using that automatic contact option. So down in the lower right there, make sure to see that tolerance value and then the contact type. So if you want to set your model up so everything's got separation contact, you can change that there and specify a tolerance. Another way you could do it, if you've got one part or a couple surfaces that you want different, you could use the automatic contact to go in and define a bunch of contact pairs and then manually specify which ones you don't, that you want with separation or something along those lines.
So in the first example, when we created that automatic contact, it set them all by default to bonded because this was set to bonded here. So if they were all with whatever contact type we set here, it will assign it to the automatic contact pairs that are generated. Then, like Andrew said, you can go in and set the exceptions to that general rule. And also, I'll touch on this.
Okay, so we do have a question here too about mesh refinement. So the question that was asked earlier was more about adding mesh refinement to the model, and we can go ahead and do that. So Marwan, if you go ahead and I believe if you right-click on the mesh model in the tree, there should be an option there to add refinements. Yep, and then add mesh control down the bottom there. So now you can select either a vertex, an edge, or a surface or a face, and you can define a different mesh size or element size in that region. So you can have that localized mesh refinement that you're familiar with packages like SimMechanical or ANSYS. Let's see. So another question, what about if I want to set up some contacts to be bonded and others to be surface? Do I have to set this up manually for all? Yeah, so what you'd have to end up doing is defining all those contact pairs and then specifying one specifically to be bonded or others to specifically be the separation contact in In-CAD. Now you could use the there is when defining a manual contact pair, there's the option to do automatic That'll search out all the surfaces there if you don't define any. That may be a good approach, but at the same time you don't really necessarily, there's not a good way of seeing exactly what's being defined there. So the better approach, in my opinion, is to go in and make sure you get all those contact pairs defined, and that way you can set them up in the manner that you're looking for.
Yeah, and in more complicated geometry, it'll be hard to see where those, like in the example I did, the first example of the joint, it wasn't too bad. But if you have much more complicated geometry, when you look at that list, maybe we had 7 or however many, but you could have, tens of them, and it'll be more tedious to just go in and try to locate where each one is and make sure it's the correct contact type. And the way I did the model probably would have been easier if I set the default to separation and then just went in and edited just the one contact pair to make that bonded, rather than the opposite, which it automatically generated all bonded, and I went and I left the one alone and changed all the rest to separation. Should have went around it the other way around, which is set the default up here from default setting to no, not from default setting, I'm sorry, from analysis. Set that to separation, and then just went and changed the one to bonded. So there are multiple approaches. You just want to take the one that is quickest and most convenient.
All right, it looks like the stream of questions have kind of died down here. So we'll give everyone another minute or two if they have any last questions, and then we'll go ahead and end the webinar. All right, well, I want to thank everyone for joining us this morning. We'll be meeting again in 2 weeks, and I believe that week we'll have Dean Rose and one of our other technical simulation sales specialists to answer some of your questions, and I look forward to seeing you all then. Thanks a lot for attending.